Hi there, I'm Chris Saxon, SQL Wizard. In the previous episode, we saw how we used temporal validity to change the value returned by a query. Today we're going to take a look behind the curtain and see how you can use temporal validity yourself. Let's get started. Here's my table definition. We've got our message column, and there's also this period for magic clause. And this is what enables temporal validity on the table. Let's create it and take a look at it. Bringing it up in the schema browser, we can only see one column, message. But this period for clause has actually created some hidden columns for us in the background. We can see that by querying user tab cols. We get our message column here, but we also have three hidden columns, magic, magic start and end. And these are used to control whether or not we see a row in the table when querying it using temporal validity. Now these hidden columns don't appear by default, i.e. when you're issuing select stars, describing the table, or viewing it in the schema browser. However, you can reference these columns explicitly to get their values. Having created my table, the next step is to actually insert the data. Script to do that is here. First step was just to take the current date and stuff it into a variable. Then inserted my three rows with consecutive time periods. First one starting from the current date up to 30 seconds, next one from 30 seconds up to a minute, and the final one from a minute to the following day. And if we commit that, and set the valid time to current, this means we only see the rows where sysdate is between the start and end column values. So let's just run that, and we can see that when we query the table, we just get our first row back. Now because magic start and end are hidden, we don't get them in the select star, but we can see them explicitly, like so. And we put our valid time back to all, and query the table again, we'll see that we get all three rows back. That explains where the first three value changes came from, but where on earth did all those bananas come from? Let's have a look at another script. After creating the table, I then altered it to add another period, a banana period. Let's do that. We can see that this adds another three hidden columns to the table for my banana period. The real insert statements then actually had to include the banana start and end columns. And then we defined the first three rows ended for the banana period 3 minutes in. Now notice the banana start is null. Oracle defines plus and minus infinity, that is the first and last rows in your result set, as null when using temporal validity. No magic values here. So we've got our three rows which end 3 minutes in. We then got our banana rows which start 3 minutes in and continue on forever. Now the magic start and end columns for my banana rows have actual real values assigned to them. If I had set these to null, then when we set the valid time to current, then all these banana rows would have appeared every time. Let's insert that information. We can query the table. We can see we've just got my one row, but when we set the valid time to all, we can see we've got all the rows. Now if you recall back to my previous video, when I was set it to all, I put these conditions in. This is a little bit of sleight of hand to hide those banana periods from you when I was explaining the trick. So how is Oracle doing this? So it only returns us one row at a time. Let's take a more detailed look. Now this is pretty neat, but you may be wondering, how does Oracle actually control which rows are displayed? We put the valid time back to current and take a look at the explain plan, we can see a bit better what's going on. Oracle has automatically added these extra predicates to our query. It's checking whether any of these hidden columns are null, and whether the start values are less than or equal to sysdate, and whether the end dates are strictly greater than sysdate. So it's added these conditions to us, to our query, so when we execute it, we only see the rows that are active within the current time period. We can see that if we use the as of syntax for the valid time, set that to 1st of June, when we look at our explain plan now, it's piped in the 1st of June as our valid time period, rather than sysdate. Now, this is pretty cool, but it's also quite powerful and could be potentially confusing. You may not want to set across the system to view rows that are currently active or at a given point in time. You may want more control than that at the statement level. Fortunately, you can do that too. You can do this by specifying this as of period clause in your queries. So what we're doing here is saying we want the rows for the banana period that are currently active. If we query that, we just get our banana rows back. Another look at the explain plan, we can see it's added the conditions just for the banana period. Now, a common use case may be that you only want to return the currently active rows. You can do this by creating a view which includes the as of syntax in your query. So if we do that and look again, we just get our banana rows, and we can see the explain plan has added the conditions for us. You may be saying to yourself, this is pretty cool, but I don't want invisible columns. I want real columns I can actually see in SQL Developer. Does temporal validity work with these? Well, yes it does. Let's take a look. Imagine you want to capture changes to people addresses over time. Now, the moved in and out dates are important to you. So you don't want them to be hidden columns, you want them to be real visible columns that everyone can see. You can do this by creating your address history table and specifying moved in and moved out. Then when you define your period, you just include which date columns make up that period. Create the table and insert a row. When we query it, we see that moved in and moved out date are normal visible columns in our table. And when we look at user tab cols, we see we don't have any additional date columns that are hidden. Moved in and moved out are the columns for temporal validity. We can prove that by doing an as of query. So if we look at the currently active rows and run the explain plan on that, we can see that Oracle's automatically adding the conditions to the moved in and out date columns. We've seen how temporal validity works. You may be wondering, what can you use it for? Well, basically, anywhere where you're capturing changes to values over time. We've already looked at address histories, but you've also got things such as job history and order change histories. If you're in a data warehousing environment, all those slowly changing dimensions with start and end dates are a perfect use case for it. That was the what. How about the why? Why bother to use this when you can just code it all yourself? Well, when you're coding it yourself, you can be pretty sure that each developer will come up with a different method for handling time periods. Some will use magic values for plus and minus infinity, others will use null. Some will use inclusive time boundaries, others exclusive. By using temporal validity, you take all those questions away and ensure that time periods are handled consistently throughout your application. That was our behind the curtain look at the magically changing row trick. I'm Chris Saxon, thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.